I'll take an example of a computer network and show you how does the actual things work in computer networks. Let's say you are in India and this is somewhere on one network, Airtel network in India, and this is your host. Host means your computer. See, this is the network. Let's assume this is the Airtel network in some region in India, and this is your host, and this is a process. Okay, process. So what is it? Network, and within the network there are many hosts, and one of the hosts is your computer, and the other one is within a host there are many processes, and one process is you have opened your web browser and you have typed say google.com. Now you want to go to Google and get a web page, and assume that Google's network is in California, somewhere in US, and this is the network in which Google is present. And now inside that network, one of the server is Google server, this is the host, and one of the process is the server which you want to connect, which means from your process at home you want to connect to the process of Google in order to get the web page, right? So what did you type in your web browser is www.google.com. Now when you type this that name, domain name, that domain name has to be converted in such a way that you are going to identify the network here. See, which means your request has to start from here and it has to first reach the destination network, isn't it? It has to reach the destination network, and after reaching the destination network your request has to reach the host, destination host within the network, and after reaching the destination host it has to reach the destination process, right? Therefore step 1 is your request has to reach the destination network, and step 2 is your request has to reach the destination host, and step 3 is your request has to reach the destination process. There are 3 steps involved in here, right? So in order to identify the network, the destination network and destination host, you have actually given only www.google.com, the domain name, right? So you gave only this www.google.com, and now using this name, this domain name, we have to identify the network and then the host and then the process, right? So somehow we have to convert this domain name into some numbers so that it can be identified. So there has to be a service which converts the domain name into IP address. Why IP address is, IP address will have 2 parts. One part is called network ID and other part is called host ID. Therefore using network ID we can reach the target network, and using host ID we can reach the target host. And then in order to reach the process we need something called as port number. Since you are talking about web service which is HTTP, all the web services will be run at port number 80, that is globally known. So everyone knows that if it is a web service it is 80. Therefore in order to reach the process the port number will be used, which is already predefined as a well-defined port, right? So this is how it happens. First thing is your domain name has to be converted into IP address, and your IP address is going to have 2 parts. One is network ID and other is host ID. Network ID is used to reach the network and host ID is used to reach the host. And then in order to reach the process we actually need the process number also, which is nothing but port number, and most of the port numbers are already predefined and they are fixed, right? And for the well-known services, since it is a well-known service it is fixed. If it is not a well-known service you should even know what is the port number at which the target server is running. For example, FTP it is 21, SMTP it is 25. So likewise we have all the for well-defined ports, for well-defined services we have well-defined port numbers. Now the step is, how are we going to convert this domain name into IP address? So in order to do that, see, one thing is, if you know the IP address directly you can contact the server, but then it is very difficult to remember the IP numbers, right? Because we are good with remembering the names rather than remembering the numbers. That is why your ISP, Internet Service Provider, is supposed to provide you with a service called domain name service, which means inside your network itself it is supposed to configure a domain name server. So before actually contacting the Google, you will actually contact the domain name server and ask for the IP address of what is the IP address of google.com, and now DNS is going to return you the IP address of google.com. Once you get the IP address of google.com, you can directly reach it. Now this entire procedure, which is converting the domain name to IP address, is actually an overhead. See, we wanted to reach Google, we didn't want to reach DNS, but then we had to reach DNS because we want to convert it, right? Therefore this entire step is called DNS overhead. So what we generally do is, we don't go to DNS all the time. We generally do it for the first time, and then we save the IP address in our computer for some time, and whenever it has expired, generally we use a log for some time, and whenever it is expired, again we will go to the DNS. So first time when you are contacting any server, sometimes the service will be late because there is DNS overhead. Second time if you use the service, then it will be straightforward. Right. So one thing you should note is, the main important thing in this communication is IP address. So let's talk about IP address in detail, and before talking about IP address, I want to talk even about the binary numbers. Okay, so we shall talk about binary numbers and then IP address now. Yeah, so now let's see about IP addresses. Before going to IP address, I want to talk about binary numbers a bit. So binary numbers are, this, right? Number system has evolved, and the first number system was unary, right? So what is unary number system is, we have only one symbol, which is nothing but 0. So this is the most popular number system, even you have used it in abacus long back in your childhood, right? So if I had to represent any number like 1, I represent it using 1 0. If I had to represent 2, I represent using 2 zeros. If I have to use 3, I know it is 3 zeros. So this is nothing but unary number system. And after that unary number system, the most popular number system is decimal number system. In decimal number system, we have 0, 1, 2, 3, so on 9, which means 10 symbols. And you are very much aware of it. Now the next number system which is popular is binary. Because of the invention of the computers, we have been using binary. In binary number system, the base is 2, and therefore the number of symbols we have is 0 and 1. So always remember, if the base is n, if the base of a number system is n, we have n symbols in the number system, and all the symbols will be starting from 0, 1, 2, 3, so on n minus 1, right? And now the binary number system, we have 0, 1, and then we have hexa, octal number system, in which the base is 8, therefore the symbols are 0, 1, 2, 3, so on 7. And in hexadecimal number system, we have 16 symbols, but then since we have only 10 digits, 0, 1, 2, 3, so on 9, we have used A, B, C, D, so on F as the remaining 6, right? So these are 10 and then 6, that is why it is hexa. And now A represents 10, B represents 11, and F represents 15. Okay, so this is all about the number system. So we have all these number systems, but no, the most popular number system is binary coming to computer science. Therefore I would like to, I'd ask you to be very good with binary number system, especially the powers of 2's. And coming to this, you should have a grip over these numbers. So 2 power 1, 2 power 1, 2 power 2, 2 power 3, so on, 2 power 10. 2 power 10 is nothing but 1024, and sometimes it is also called as k. K represents 1024. Okay, and then m represents 2 power 20, g giga 2 power 30, t tera 2 power 40. So you should be very good with all these conventions, notations. What is m and what is g, what is t, especially in computer science it is going to be very important. And we shall talk more about binary numbers once. Let us say I have one binary bit. With one bit, how many numbers are possible? How many binary numbers are possible? Okay, so with one bit we can have two binary numbers, 0 and 1. If I have 2 bits, if I have 2 bits, how many binary numbers are possible? I can have 4 binary numbers 0 0 0 1 1 0 1 1, which means 0 1 2 and 3. With 3 bits, how many binary numbers are possible? You know it is going to be 8, right? Why? I have 3 blank spaces and 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, now this part you know it well. Now next thing is, if I choose one bit, how many parts will I be dividing the entire space into? Let us say this is called the address space or number space. With 2 bits this space contains 4 numbers. With 3 bits this space contains 8 numbers, right? So now my next question is, let us assume that we have such a space, and now if I choose one bit, let us say I am choosing the first bit. If I choose one bit, how many parts will I be dividing the entire space into? It turns out that we could divide this entire space into 2 parts, isn't it? If I choose one bit, I am dividing the entire space into 2 parts. One part contains all zeros in this selected bit, and other part contains all ones in the selected bit, isn't it? So if I choose one bit, I am going to divide the entire space into 2 parts, isn't it? Now in this space also, just check it. If I choose one bit, the first bit, I'll be dividing the entire space into 2 parts. One space will be having zeros in the selected part, and other space will be having ones in the selected part, isn't it? Now if I choose 2 bits, then I'll be dividing the entire space into 4 parts. One space will be having 0 0 in the selected locations, other space will be having 0 1 in the selected location, other space will be having 1 0, and other space will be having 1 1, right? So if I choose 2 bits, I'll be dividing the entire number space into 2 power 2, which is nothing but 4 parts. So similarly, if you have chosen 3 bits, then how many parts would you be dividing the entire number space into? 2 power 3 parts, which is nothing but 8, isn't it? If you have chosen 3 bits, then how many parts would you be actually dividing it? Which means, all the bits are going to be distinct and every number is going to be in a separate part. Therefore you are going to get 2 power 3 parts, which is nothing but 8 parts, right? So one thing you have to note here is, if I have a n bit number, a number is containing n bits, then the total number of bits or numbers present in the number space is 2 power n. So 2 power n numbers will be present in this space, right? And if I choose k bits anywhere, first leading part or any part, if you choose k bits, then you are dividing the entire number system into 2 power k parts, isn't it? So totally there are 2 power n numbers. By choosing k bits, you are dividing it into 2 power k parts. Therefore what is the size of each part? See, we have 2 power k parts which are containing a total of 2 power n numbers, isn't it? Then what will be the size of each part? Each part size will be 2 power n divided by 2 power k, which is nothing but 2 power n minus k. So this is important. Now coming to computer networks, this n bits is nothing but IP address, and the k bits which I choose is nothing but network ID part, and n minus k bits is nothing but host ID part. So if I choose k bits, then I will be getting 2 power k networks, and size of each network is 2 power n minus k. It can be extended even to operating systems. In operating systems, this n bits is nothing but generally the address of a memory, and the k bits is nothing but the page offset or page number or block number or segment number, and the remaining bits are nothing but page offset or page size, right? And coming to computer organization, this n bits is nothing but the address, and this k bits is nothing but tag or block offset, and this is nothing but block size, and this is nothing but block number. Okay, now this n, coming to this computer networks, we have IP address whose size is 32 bits, right? In computer networks, the IP address is going to be 32 bits. 32 bits, okay. And now these 32 bits, initially what they did, using these 32 bits, we know that the number of IP addresses possible, total number of IP addresses possible is 2 power 32. That is what we know. And now what they thought was, initially when the computer networks was first introduced for ARPANET and other networks, they divided it into static parts like this. They divided this 32 bits into 8 bits of network ID and 24 bits of host ID part. With 8 bits of network ID, how many networks do we get? 2 power 8, which is nothing but 256. And with 24 bits, what is the size of each network is? 2 power 24. 2 power 24 is nothing but 16 million hosts, which means if I use this classification of 8 bits for network ID and 24 bits for host ID, I am going to get roughly 256 networks, and size of each network is going to be 16 million. So 256 is a very small number. In 1980s and 1970s, this 256 number was enough. The reason is computer networks used to be the networks used to be very small. I mean, there used to be very less number of networks. Every college used to be one network, and roughly there are hundreds of networks, even less than hundreds. So initially when they proposed this ARPANET and all, 256 networks was good enough. But if you take today's networks, even in one city, if you take any city like Delhi or Hyderabad or Mumbai, even in one city we are going to have 256 networks. Therefore this is clearly not scalable. So we didn't use this at all. And moreover, if you buy one network of this size, we are going to get 16 million IP addresses, and 16 million IP addresses is too big number. No practical networks other than this NASA and Pentagon have a requirement of 16 million hosts. Therefore this system is not really scalable. That is why they have gone for the next one, is classful number system, classful IP addressing. So we shall discuss about classful now. Let's see how the IP addresses are classified in classful manner. So we know that IP address is a 32-bit number. So let's see. So IP address is nothing but a 32-bit number. 32 bits were there. And in this using 32 bits, what is the total number of addresses we get? The total number of addresses we get using 32 bits is nothing but 2 power 32. So 2 power 32 numbers we get in this, right? So what they did was, instead of dividing it directly into network ID part and host ID part, they used some other way which is actually scalable. So they have chosen the first bit. The first bit has been chosen. If you choose one bit, we have seen this in the previous lecture. If you choose one bit, we are actually dividing the entire IP addresses into two parts. This 2 power 32 numbers will be actually divided into two parts. One part will contain 0 in that first bit, and the other part will contain 1 in the first bit, right? So total numbers were 2 power 32, and I have chosen one bit, because of which we divided the entire numbers into two parts. Then what is the size of first part and what is the size of second part? The size of first part is 2 power 31. The size of second part is 2 power 31. The reason is 2 power 32, when it is divided into half, we are going to get 2 power 31 and 2 power 31, right? And now the second part, the first part has been left out like that, and now they have chosen the second part. If you look at the second part, how many numbers were there in the second part? The total number of numbers present in the second part are 2 power 31, right? And moreover, our IP address was 32 bits, out of which first bit is already chosen. We had 32 bits, out of which first bit is already chosen, and that bit is set as 1, right? And now in the remaining part, the size of this total part is 2 power 31. This one is 2 power 31. So in this 2 power 31 numbers, I am going to choose the second bit. So if I choose the second bit, then I am again dividing the entire entire addresses into two parts. The first part will contain 10 as the leading bit, 10, 10, so on 10, and the second half will contain 11, 11, 11, 11, so on, right? Now the actual size of this entire number space is 2 power 31. I divide into two parts, therefore size of each part is 2 power 30 here, 2 power 30, right? And we don't do anything with the first part, and we take the second part. Now if we take the second part, how many bits? Our IP address is, no, it doesn't change, it is having 32 bits as usual, but then out of which the first two bits are already fixed as 1 1, right? And how many bits are remaining? The number of bits remaining is 30. Therefore the total size of this entire number space is 2 power 30. Okay, now in this 2 power 30, I'll choose the third bit. So first two bits are already fixed, which is 1 1. Now I am choosing one more bit, because of which the third bit, because of which the entire number space is divided into two parts. The first part will contain 110, 110, so on 110, and the second part will contain 111, 111, so on 111. Now what is the size of each part? 2 power 29. Why? Initial size is 2 power 30, out of which I have taken this. Even if you didn't understand this, maybe since we have fixed up 3 bits, how many bits are remaining now? 29 bits. So how many numbers do you get with 29 bits? 2 power 29. Even you could use it that way also. Now I'll not do anything with the first part. I'll choose the second part, this part. And now our IP address is as usual 32 bits. How many bits are there in here? The number of bits in this one is 3 bits, right? So already first 3 bits are fixed as 111. Then how many bits are remaining? 29 bits. Using 29 bits, what is the size of the entire number space? 2 power 29. Now I'll choose the fourth bit. If I choose the fourth bit, then I am dividing the entire number space into two halves, right? So one half will contain the total number of bits remaining is 29. Therefore the size of this entire number space is 2 power 29. Now the first half is already containing 111. Now I have chosen the fourth bit. The fourth bit could be 0, which means in the first part all the numbers will contain 1110, 1110, right? And in this part all the numbers will contain 1111, 1111, so on 1111, right? Therefore what is the size of this part? Size of this part is 2 power 28, and size of this part is 2 power 28, right? So this is how they classified the entire IP addresses into. Now the first part which starts with 0, they called it as class A, and the second part which starts with 10, they called it as class B, and the third part which starts with 110, they call it as class C, and this one as class D, and this one as class E. Now we shall go into each class one by one, and we shall discuss what is about them.